Excellent. Recording is starting.
You're recording. Okay, let's just make sure we're all loud enough. I don't know if there's a way to phone.
My bad. Just missing.
I'm talking into the microphone. Can you guys hear me clearly now?
Still really
Not
quiet.
very clear, you're very quiet.
We're at full volume an hour as well, I think.
That is odd.
Hello, can you hear us? Can you hear us?
Yes, but you're quiet.
Let's see if we can.
Total high tech.
Is there a way to.
It's not just they've got to turn their volume up.
Well, they said they've got their volume all the way out, so. I don't know. I don't think we've got the. We can control the microphone at this end. If you guys can't hear as we go, then just let us know.
Check. Can you hear us? Check.
We can hear you. Can you guys hear us?
Yes. Okay, we are away.
You guys are very quiet though, so you might just have to use your.
I can yell, not a problem.
Yeah, we just turned you up at this end. I don't know if that affects the microphone or not, though. Guess we'll just have to wing it, or we could probably. You could probably talk into your laptop. Someone's feeding back. Let's start and let's see if they can't hear the content, we'll fix it.
Okay, welcome everyone. I wanted to thank first Rohan and Alistair for giving me this opportunity. This is going to be the first of 3 sessions on applied clean code. The first one will start off with the core design principles and some of the practices that come from the agile world. A lot of it, in my experience over the last month or so, I mean, I've seen us do a lot of it. So a fair bit of it should already be obvious and already be something that we're already doing. Don't be surprised if I am repeating stuff, and if certain sections are repetitive, let me know and I can just quickly go over them. Now, first question, does anybody know what the picture on the top left is?
Yeah, it's a picture from the clean code book, right?
Excellent. So you get a chocolate. Since you're not here, Simon is going to give you the chocolate. If you are here,
Simon in New Zealand.
It's Twine.
Yeah, it's Simon.
On the camera.
Twine works from home. He's in this office all day.
Okay. Yeah. So anyway, I'm hoping that the session is going to be interactive, and I'll be asking questions. And even if you give approximately correct answers, you get a chocolate.
We'll send around digital chocolate afterwards.
Oh, we can send digital chocolates, or yeah. Unfortunately, that's not vegan. So if there are any vegan guys, let me know. I'll take you out. So, all right. So who am I? That's my cat. That's not me. I have been developing software for a bit now. I love coding. Check out some of my projects on GitHub. As with all hobby projects, I start with a lot of fanfare, and then along the way I lose interest. But there are some interesting stuff there. So check them out. Okay, so what's the agenda for today? So this is around the core set of software design practices and software design skills, right? First, we'll look at how we measure software design. What are the ways to measure software? So you can take a look at you can take a take a look at a piece of code or design software design and actually assign numbers to it, saying that it's that much there, it's not all the way there, and things like that. The idea being that only when you measure something you can actually actionably work on it and improve it. Number two is software design rot. Why does it rot in the first place, and what exactly rot is? Number three, what are the signs of design rot? What are the smells? And again, smells do not necessarily mean something is rotting, but they're an indication more often than not. Then we look at some of the tenets. These are some of the underlying philosophies, underlying principles that enable the simplest design that ships, gets the work done, and is clean. Finally, look at the solid. Solid is something that has come from Michael Feathers and Bob Martin. This is pretty interesting. We'll come to it. And then finally, merciless refactoring. So refactoring is essentially the core goal of the entire clean code series. This is what we are after. And the reason for that is we want to be able to go as fast as the business wants with a piece of code. We want to be able to add features. We want to be able to add, whatever is required at that point of time, right? With a fair bit of guarantee on the quality, on the outcome at the end of it. So merciless refactoring, we'll take a quick look at it, but then again we'll come back to it. So merciless refactoring is going to be the theme for this entire clean code thing, right? So simple code is going to set us up for it. The developer testing part of it, which is the next talk, will enable us to have some guardrails, and then I'll take us through a bunch of other cool stuff. All right, so measuring software design. Okay, so how do we measure software design, right? And this is one of the philosophies. This is not necessarily the only philosophy. This comes from Robert Martin's school of clean code. There are a lot of other equally effective schools of clean code. So it's not really religious, but it's something that works, and something that has anecdotally proven to work, and I have seen it work myself. So it's something that it's nice. So what are the parameters, right? So first we have nameability, cohesion, right? Cohesion is basically how well a set of things like to stay with each other, right? It's sort of you can think of it as a gravity. They try to orbit each other. They have a meaning together, and all philosophical stuff we can get into. But the idea is that once something is cohesive, we can actually give it a good name. But if something is not cohesive, you'll have a really hard time naming it. Right, and typical violations of cohesiveness are if you see a class with and, or if you see a class, well, not necessarily violations, but more often than not, they indicate that there is some lack of cohesion. So if there is something with and, A and B and C class, or some class with utilities in the end, these are typically where we tend to put things together that don't necessarily belong at the same place. Then again, it doesn't mean that we need to religiously avoid all such things. There are always exceptions, but in general, those are the indications. Testability, right? So again, how well the pieces of units of code are decoupled from each other, and the test for that is how well can you test each unit of code in isolation, right? So if two things are highly coupled, then you cannot test one independent of the other. And there are systems that I have worked on in the past where you pull a thread and it brings down the entire wall. So if you know what I mean. And again, so that's the skill that us developers we perfect, right? That's what is the practice that we do. Right now, the great test for this is testability. So if there's a test failing, is the test failure due to the system under test, or is it due to one of its dependencies, right? So if it is testable, you can assume that it's decoupled. Then the third one is no duplication, clearly, right? So duplication indicates some abstraction that hasn't been spotted or hasn't been pulled out of the code base, right? And duplication can occur in many forms, right? There could be a structural duplication for which .NET introduced the concept of generics. There could be test data duplication, for which we have the the attributes and the test parameters. What is it? Theory driven test. Theory is in XUnit it's called theory. I don't know what it's called in MS test. So there are various kinds of duplication, and duplication typically means that there is some abstraction that is waiting to come out, right? But hasn't been pulled out yet. And finally, comprehensive unit tests, right? So unit tests, and this is something that we do really well in EDMI. EDMI is, believe it or not, is only my second company that I've seen takes tests religiously. Right. So this is really a pleasure for me to work with you guys. So again, unit tests, I'm not going to preach to the choir because I think we already know what unit tests do and why they're required. Now, this talk covers design at a component level. There are a bunch of other designs. It's one of the slides I haven't prepped. I'll prep it for the next one. This is essentially design at various scopes. So this is the innermost component level. Then there is outermost legacy code refactoring. Then there is a shell around that, which is OO and functional. And there's a shell around that, which is clean architecture. And then there's a Uber shell, which is domain-driven design. So at each level, you're making your system bigger and bigger and bigger. But we're going to focus on the component level alone, and component as in like a bunch of classes or a library or that kind of stuff. But this is the critical, this is the building blocks, this is the core skill set, in my opinion. We'll cover some of this in the next set of talks, right? But we'll just jump across. So questions, anybody so far? Okay, not to worry. Now the interesting thing here is that based on these four parameters, you can actually take a look at a piece of code or a set of classes or a set of units, and you can actually measure them, saying that this meets the nameability, this meets testability. Well, it's not fully testable, but it's partly testable, and then you can actually come up with an objective number, saying that what requires further improvement. If it doesn't have enough test coverage, then put under test, and you suddenly. So these are essentially the four parameters that you can use on a day-to-day basis. Right, and this is something that I do normally. So as soon as I get into a code base, brand new code base, these are some of the these are sort of the temperature checks I make. And these, more often than not, this will tell you where to focus first up. Yeah, we'll jump across. Okay, now software design rot, right? Why and what? So why does software rot? Somebody, can you give me maybe one reason, two reasons, three reasons? And yes, you get a chocolate for it. Wrong or right?
Like using old libraries and stuff like that are outdated.
Yeah, outdated. Sure, outdated. So you get one.
Yes.
What else? Okay, let's take a look at a few reasons, right? So requirements change in ways that the initial design didn't anticipate. So this is the least surprising of all, right? This is where Agile came into the picture, and sort of Agile was a disruption in the industry. Waterfall, I've been in Waterfall where we used to write design specs for good 2 months. There used to be a specific milestone for it called M0. There was a 2-month milestone. We figure out every nook and corner and then come up with this huge design doc that you implement in the next 6 months.
And to have it all fall apart right at the end.
No, it's worse. We stop listening to customers and we fix the product, and we essentially suit the facts to fit the theory, if you know what I mean. So it actually becomes pretty worse. And yeah, this is some of early Microsoft. That when I was there at Visual Studio Windows, we're all guilty of this. Right. So Agile was a disruption here. Right. Agile said just do just in time. Right. And a lot of people back who are very comfortable with the upfront design, they are like, it's sort of a repulsive ideology for them. It's like, no, I can't do that. Then changes need to be made quickly. Again, surprise, surprise. And finally, it's typically made by somebody who's not familiar with the original design philosophy, right? Yeah, we typically have experts around, but they usually don't do all the design changes themselves. You usually employ somebody who may not be familiar with the original design. Right, these are some of the 3 reasons why software rots, right? So you can think of software rot as second law of thermodynamics, where entropy of a system tends to increase. Entropy means the measure of disorderliness in a system, right? So things tend to go from state of order to a state of disorder. Right, and so this is classic entropy problem. Right, now what are the signs of software rot? Again, so these are some of the most common ones. This is all from Bob Martin's School of Software, Clean Code. So there are seven clear signs that we can spot on a day-to-day basis, and that will tell us whether those are actually indications. And again, these are smells. Sorry, these are smells, and again, smells are not sufficient to tell you that something is rotting. Smells are more of an indication, right? If something is smelling, so that's it. And it may not be. You don't need to fix it right away, but more often than not, it's typically indicative of something rotting. All right. So first one, fragility. Program breaks in many places, even unrelated with a change. Right. So this one should not be a surprise at all, right? So very often we come across code bases that in my previous company I was maintaining a mission critical code base, which is essentially the time sheeting system, right? What did you say? Time sheet system. Okay. So then we had, there was an Angular 2 component and there was an Angular JS component, and they all shared certain, non-obvious styles and non-obvious functionality, and you touch one and things break, right? So this is classic. You call something as fragile. Second one, rigidity, right? So you cannot make one change without causing a cascade of changes in dependent modules, right? So this you pull one stuff. How many people can identify with some of at least these two? Does it make sense? Have you guys seen it?
Yes.
The third one is immobility, right? Now, more often than not, right, we put a lot of effort in writing a piece of code, and that does the job very well. But very often we see that with slight modification of that piece of code, it can be made to do a bunch of other things as well, right? But what happens is that the code is so enmeshed, so embedded, that it takes a lot of effort to, even pull it out. I have been guilty of this myself. There was my last year in Windows. I actually copy pasted 5,000 lines of code, did a Control-Shift-F, Control-Shift-H, changed resync to consistency check, and checked in the code. So they were essentially doing the same thing, but it was 5,000 lines of C++ code. So that's one of the sins I've committed, one of the many sins I've committed. Viscosity, right? Viscosity again. So when something is viscous, it's hard to. There's a lot of resistance. That's what it means. Now viscosity comes in two flavors. First is the software, and it's easy to. It's like it's much easier to hack than to preserve the design, right? You may not be knowing the original design, or the original design might be a smelling of a bunch of the other things, for which you're just easier to just kind of move on. Or you might even have somebody breathing down your neck saying that, hey, I need to ship this feature day after tomorrow, or rather I need to ship this feature yesterday. Give it to me, right? So you typically kind of just hack it and move on, right? This is fine. None of these are taboos, right? These are something that we do, and these are something that is this is something that is always there. It's a part of the game, right? But again, these are smells. Then the second one is environmental viscosity. right, the environment is inefficient. And when I say inefficient, it is like really inefficient. Case in point, Windows XP build or Windows Server 2003 build used to take 26 hours, which means 26 hours, and across, I think there were about 10 depots. Depots, I mean source control system. So each top level team checked in, like there was a basic, the kernel team checked in their own, the devices team checked in their own, right? So this guy had to pull everything in one place, build it. It went on for 26 hours, and that was just the build. And after that, you ran the build verification tests, and if that failed, that entire build is redundant. Right, so basically by the time I am done committing my code, it's day after tomorrow I can come to know of its state. So that's an extreme, right? But we've seen many ways, right? Like environment is inefficient. Like maybe there is a huge process in place, right? Or maybe it's very hard to get feedback from the code saying that, hey, did I do the right thing or not? In the libraries team, the part that I have been working on, it's been very efficient. I think that's the part I love. I've rarely seen any viscosity in terms of the software or the environment. I think it's fairly well managed, right? So then there are three more. Again, needless complexity, right? So we have constructs present that aren't currently useful, but used to be useful at some point of time, right? And these are like layers and layers of classes and layers and layers of classes that could have been combined. Maybe they were serving some purpose, but right now they aren't, right? And what's the biggest problem with needless complexity?
I'm not very clever and I don't understand it.
Yeah, it's hard to read.
Hard to pick up.
Yeah, hard to read. Chocolate for you, sir. I don't know your name, but
That's Simon.
oh, Simon. Okay, you can give yourself a chocolate.
Thanks. Don't mind if I do.
You're welcome. Needless repetition. Same pattern appears repeatedly. Fixes are multiple and non-identical. So in the code that I had copy pasted, the 5,000 or 5,500 lines of code, guess what? If there was a problem with the resync, and resync essentially is syncing two virtual machine VHDs across two sites, right? And there was a consistency checker which essentially did the same thing, just compared that the resync went fine. So if there's a bug in one piece of code, it would take me 26 hours to figure out what that bug is, and then after 26 hours come back, and then life goes on. So
I'm not a developer, but like here you'd be talking about using classes that, or a PowerShell internal module that you could reuse.
Exactly.
Yep.
Right. So this is essentially a duplication, like dry, repetition, and repetition can come in many forms, like structural repetition, code repetition, test data repetition. There are various kind of it's essentially some abstraction waiting to come out.
Yeah.
Opacity, right? So modulo is difficult to understand, especially after intimacy is worn off. I think there's some law. I don't remember what that law is like. It says that after a few months, your code is as good as anybody else's code. Like unless you take care, you can get into it, and then you can't figure out head or tail. And I'm guilty of this. I'm absolutely guilty of this. These are so many of the sins that I have committed in the past, and I still commit. But the idea here is that the first week a developer writes the code, it's all very clean and all very obvious, and it's all great and hunky dory, and I can fix the bug anytime I want. But then the test is 2 months down the line. What happens? So the intimacy factor here is the non-obvious factor, right? Okay. How are we doing with time?
You're on slide 8, so about 3 slides behind.
Okay. Okay, so software design tenets. So tenets are essentially, kind of pillars, kind of underlying, themes and recurring themes all the time, and it's some of the non-obvious stuff. And again, so this is one way to name it. I haven't been in EDMI for long, but I am pretty sure you guys do similar stuff called with different names. Right, so feel free to, call me out on that. Right. So first one is ruthless Yagni, right? You aren't going to need it. How many have encountered Yagni before?
Yep.
Okay.
Use it
for
all
you,
the time.
Chocolate for okay, chocolate for you, sir, as well. I don't know your name.
Adam.
Adam. And if you want another, you can get you another. Okay. So again, the philosophy here is approximately right isn't better than exactly right, right? So you want things just in time. Cleanest possible code that works is the thing, right? You don't want perfect code. Nobody wants perfect code. Second one is do not repeat yourself. So this is dry, right? Again, so dry is, we'll come to dry. Dry is actually pretty funky. And again, the key thing to note here is that, software design, what we say software design, it's really a process. It's not an event. It's a sort of continuous investment, right? It's like the air conditioner pumping heat out of your room constantly, right? So you don't freeze your room and then leave it. The air conditioner switches on, pumps the heat out, and then switches off, and again it becomes warm. So typically the flow is this, right? You mess up, also known as deliver features. Then you detect, right? Some of these help you detect. These smells help you detect. Then what you do is you diagnose. Diagnosis in like really what to do about this and what is the core and what's the root cause and blah, 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 blah. Then what you do is you repair, right? So this is where the merciless refactoring and the guide rails around developer testing, and then cycle repeats, right? So this is life in software development, I guess. Should share my screen again. Okay. Okay, great. Here we go. Okay, so we'll speed up to this because the solid is the.
Just check everyone can see the screen.
Can you guys see the screen?
Yes.
Excellent. Okay, so YAGNI is essentially you want to be able to spot the difference between what you can do and what you need to do, right? So that's the difference. That's a skill. It's everything is in the scope of YAGNI, right? So there are well, at least my philosophy is that security, API compatibility, you name it, everything falls within the scope of YAGNI for two reasons, right? So what does YAGNI prevent? So YAGNI prevents scope creep, number one. So again, product managers love this because they want to prevent scope creep, right? So where the development team wants to keep doing more stuff, but then he's saying, no, this is enough, I want to ship it, right? So YAGNI, calling YAGNI is helps in that, right? So it prevents scope creep. Then it prevents priority inversion, right? So you find yourself, you need to deliver this piece of code, but for doing this, you need another one, which is really low priority in the product owner's mind. So then you typically call YAGNI and you're done. So it's kind of a catch-22 breaker, if you will. This is most effective when it gets into team vocabulary, right? When we call each other in meetings or in team design sessions and blah, blah, blah. Of course, I've been in teams where we overdid it. Like, for example, we were taking a service. It was one of the TFS services, a load test. We were taking that service from on-prem to the cloud. And then the architect in that decides to call YAGNI to migrating it to cloud architecture, in the sense worker roles and web roles. It was olden times. So his idea was that let's just take lift and shift. So he called YAGNI in that. So that's, I think, overdoing. So again, this is a skill you have to apply. You have to go wrong, and you have to come back, and this is just like any other art, right? So dry. What's dry? Again, so this is arguably the root of all evil in software. This is where all patterns emerge. This is where all tools emerge. This is where all libraries emerge, right? And for example, the entire generics was because we didn't want to be dry, right? The .NET 2.0 introduced generics because there was a sort implementation for int, a sort implementation for string, and name it. Right. This is also the reason why C++ macros emerged. This is the reason why we have Angular, because we have React, and pretty much everywhere you can software. Like there's a saying, right? I think it was, I don't know who it was. It was one of the Turing Award winners. So he said, every problem in computer science can be solved with a layer of indirection, right? Excepting the problem of too many layers of indirection. But I guess the whole idea is this, right? So you want to be able to pull out an abstraction, right? This implicitly creates dependencies and therefore coupling, right? So this will be unknown implicit at some place. You have to make one fix, and there will be similar fix waiting for you to make, but you have to figure it out once it's deployed to production, and all kinds of notions, right? So a typical philosophy is like you get bitten once, which is essentially you copy paste code once. The third time onwards, you refactor it out. Some people do it 4th time. That's fine too. But beyond 4th time is madness, in my opinion, right? Because then, right? So it's okay to make a duplication once, like there are 2 copies or 2 similar copies or something, but 3rd time or 4th time at least, make it right. Now the kinds of repetition, right, we've discussed between software entities, between code and test code, between fixture and test code, blah blah blah. Okay, so this is the icing on the cake, right? This is. So how many people have heard about Solid before?
We know that.
Yeah, everybody should have.
Okay, I don't have chocolates for everybody, so nobody gets chocolates for this. Okay.
We're not all software guys.
Okay. So great. Okay, that's fine. Then in that case, if there are non-software guys who have heard of Solid, they qualify for chocolate. So let me know. Okay. So goals: increase cohesion, reduce coupling. This is where it becomes very interesting, right? So this essentially becomes sort of mechanical engineering, where you are looking at forces exerted by one component in the system on the another component, right? So if you visualize your system in that way, right, it becomes very fun, like a lot of fun, right? You're essentially doing mechanical engineering on your code base, right? So this is actually a lot of fun, but hopefully I get to that, right? The core idea is then to minimize the transmission of force, and this is the force of change. So in one component change, you want the other component should not feel that so-called the force of change or the the vibration in the other component. Right? So they should be fairly isolated. So that's the core idea of Solid. Again, be aware, beware. So apply only to small solid smells. Don't go around applying randomly when there are no smells. Don't overdo. Again, Yagni. Call out Yagni. Right. So there are cases where it's okay to be SRP or solid non-compliant. It's okay. It's fine. Right. But again, don't overdo it. Interesting thing is this is applicable to life in general. This is not software. So I think Bob Martin should probably publish a revision saying that Solid is no longer for software, right? So there was a slide I saw on the network, on the internet sometime back that looks like this. Sadly, this came from one of my mentors, but I'm going to beat him up anyway. What do you think? What do you guys think is the problem with this slide?
Sorry, can you just repeat the question, please?
What do you think is the problem with this slide? The one on the bottom right.
I mean, you repeat the function all over again, so you repeat the drive principle. And so the other one, exactly two different things, right? Object-oriented pattern principle and the functional programming, yeah.
Actually, it's much simpler than that. So one is obviously this guy has drunk a lot of functional programming Kool-Aid, right? He's probably drunk on that Kool-Aid. Second is take a look at it, right? I mean, single responsibility, like how he has written FP as functions for I can write objects, right? Like everything is an object in O. It's like, so what was that person trying to prove, right? So Solid is not O, or Solid is not FP, Solid is not logic-oriented programming. Solid is more. We'll come to it. Right, so I'm going to scratch this out. So this led to a pretty visceral reaction in me. I was like, obviously this person did not understand Solid. Okay, so solid, right? So S is, these are quick. I'll just jump across this, right? So these are, we'll cover this one by one. Right, this is the key summary. Hopefully, I think I will publish a chart where we can stick it on the wall somewhere, or maybe a couple of places that sort of it's in front and center of people's attention more often than not. Right. Now, what we're going to do is we're going to go through Solid, and we're going to build an application that emails the contents from some file from somewhere. Along the way, we're going to throw in requirements. We're going to start simple. We're going to throw in requirements, right? We're going to spot the smells, apply the solid principles, remove the smells, right? And then we're going to experience the amazing emergent design. So we'll see the design emerging out of, so this is classic agile, right? So we won't sit down and have a design document, 20-page design document that says, this is how the email application should look like. All right, we're going to start simple, right? So let's start. So this is no rocket science. You have an email sending app. This is going to be a class. It's going to read from a file. It's going to send the email, right? So this is the first and V1. There is going to be a session, hands-on session on day 4, where we will actually build code that does this. So we'll get hands-on experience on this. Hey, Igor, did you want control of the session? Or probably was a mistake.
Sorry.
Okay, not. Right, so don't worry, we will actually have a hands-on session that actually we build application that does the same set of things. But right now it's going to be a flow on a class diagram basis. But that's sufficient. That should be sufficient for us to see the power of Solid. What's happening? Okay. Okay. So single responsibility principle, right? Now the statement is very simple. A component should have one and only one reason to change. Right, and change here typically means in terms of people, right? People have a reason to change. So single responsibility principle does not mean a component has only one responsibility. It does not mean any of the other stuff that you may see on the internet. This is from the person who has defined Solid. So I think they're better off taking his definition. A lot of times you will see that Solid is about one responsibility, but it really doesn't mean anything, right? If a component has one reason to change, then the component is one responsibility. It doesn't mean how big it is, or doesn't mean how spread out it is. If a component has 2 reasons to change, it could be a file-line function, then it has 2 responsibilities. It's as simple as that. All right. Okay. So now we'll take a real-world example for each of them, right? To show that Solid goes beyond just software. So a real-world example would be, so typically when we have a video, right? So typically I could have made a slide covering all the 3 talks in a single slide, right? So what would be the problem with that? So I could have made a single slide with design. I could have made a single slide for testing. I could have made a single slide for legacy code refactoring, right? A single set of slides. What would be the problem with such a thing? The problem would be that if I needed to make change in one of the slides or one of the talks, or maybe one of the talks get cancelled, then the entire slide set has to be touched, right? And potentially re-reviewed, and potentially this is a sort of a not that strong a situation, but if you take a look at videos, right? So they have sessions recorded. Microsoft Build records sessions. They don't record one video for the entire thing, right? They usually record for sessions. And typically the reason is like one particular session, gets cancelled. That's fine, right? So you assign the reasons. What are the reasons for changing, right? So that's what we're looking at. One slide or one slide deck or one video for a particular topic, right, is typically has a different reason to change than that for the other one. Yeah, so that's the reason why you kind of segregate things, right? Reason for change, so that you don't have to redo everything, so that everything doesn't have, so that the force of change in one does not get transmitted across all the others, right? So this is why the others are fairly isolated. So this is essentially what single responsibility principle is. It has nothing to do with software, by the way. It also applies to software. That's a different thing. Why? Right. So each responsibility is an axis of change, right? Causes implicit coupling. Again, think of it in terms of force. So if you're wiggling one of the software, one of the components, and wiggling implies change, some change, right? How much of that wiggling is felt by the components nearby, right? So that's what you want to try and minimize, right? Again, don't overdo. Don't start splitting out every line of a function into a separate component of its own. If there is no reason to change, don't split it. Right. So application, right? So let's handle the new requirement. Let's earlier we read from a file and we send it. Now let's read from a formatted XML file, formatted as in structured XML file, and let's do it, right? So we could do it like this. What's the issue with this though? Again, hint, use SRP.
The email sender needs to understand flat files and XML files.
Very close, you get the chocolate though. Very close, right? So email sender needs to understand file handling as well as it needs to send the email, right? Email sending app is of course the Uber layer. So it is essentially doing two things that can independently change, right? You get a chocolate, sir.
I'm done. I've had any.
Excellent. Okay. Hope you liked it. Right. So what we do is so fine. We typically take a pass through this and then, we spot it out during code reviews and say, hey, this is violates SRP. Then we typically split it like this, right? So we typically say there's an email sender and there's a format reader, right? And format reader essentially just what it says. And if you can also see, right, the naming has become much more coherent now. It's much more cohesive now, right? So email sending does email sending, format reading does format reading, and blah, 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 blah. So this is SRP in action. And again, there'll be a hands-on session where we'll actually do this code. We'll actually build an email sending app. Okay, the next one is open close principle. So open close principle, the statement reads software entities. I think they should publish a revision. It should be entities should be open for extension but closed for modification. What is an example of this in real life?
Versioning.
Versioning, not quite, right? So the idea here is that to be able to extend something.
It's an API.
I can hitch a trailer to my car, but I can't add more doors to it.
Sure.
Yes. You get a chocolate. Yes.
I'm getting Simon on the chocolate.
Yes. Absolutely. Yes.
Great example.
Great example, right? The one I had in mind is a little bit different. You add a new device to your laptop. You don't essentially dismantle the laptop, add the device and put it back. You have a port for it. So that is where it is open closed, right? But the trailer example was great, right? So if you want to add an add-on to your truck, you don't want to dismantle the truck and kind of it's open for extension, but it's closed for modification. Why? Right. So again, remember that closure cannot be complete. So you can't foresee everything. You can't foresee a device that's going to come out in another 15 years and therefore design for it in your laptop. So it must be strategic. Strategic isn't like, hey, what are the most likely devices you're going to connect to your laptop, or what are the most likely add-ons you're going to put to your attach to your truck, right? So you get an idea of that and design according to that, right? You can never make it complete. So again, going after completeness is somebody is violating the AGNI somewhere. Again, closure is implemented using abstractions. It's typically polymorphism in O, and another example is dictionary-based programming in FP, right, where you are essentially attaching a piece of code in a dictionary with a particular key. This is very beautiful, which is essentially what polymorphism is, right? There's a V table, which is what dictionary-based programming is. Again, don't overdo it. So don't try predicting the future. Don't think of devices that are going to come out 20 years and design your laptop for it. You're not going to get anywhere. Again, so this has nothing to do with software. It's also applicable to software, but you get the idea. Right? Don't predict the future. Hence the strategic part. Now, solid application. Right? There's a design smell here. What is it? Actually, I'm going to be fair. Somebody already gave the answer to that. I think it's the person who got the chocolate previously. So if you want, you can collect two. This is your second.
Whoa, I'm dying.
He's already bouncing off the ceiling path, though. Leave him alone. Simon's already bouncing off the ceiling. Don't give him any more chocolate.
Okay, fine. Fine. Okay, so we weren't able to add XML file without modifying the format reader, right? So that's what is open close. So there will be a format reader, then there'll be a switch case or an if else where, if this, do this, if that, then do that. We change it to an interface, a format reader, and we typically supply the interface through DI or a dictionary or any such a number of things. Right. So this is OCP. Right. Okay. So next one, Liskov substitution principle. I think Liskov is Barbara Liskov. I think she got Turing Award for something, but I don't know. I don't remember. So statement is subtypes must be substitutable for their base types. Okay, so this is very subtle. Now, what's a real world example? I'll give a hint. We can extend the truck analogy or we can extend the laptop device analogy.
Once I've learnt to drive a car, I should be able to drive Simon's car and Cameron's car and Stephen's car and basically do it the same way.
Do it the same way, but if the interface, if for example somebody gets you a 20-ton roller truck that has the same interface of attaching to the car, then you can attach the 20-ton roller truck to your car, but you really can't do anything with it after that. Right, 20-ton or 50-ton, right? So a huge truck, so your car won't even be able to move it, or maybe even a jumbo jet, because they typically have the same interface. Or in a device, you can have a USB port, and the USB could be connected to a 50-volt power source for all you know, right? So that's going to blow up your laptop. So those are violations of LSP. A common coding violation of LSP is iQueryable, if you guys have used it. So link to object implements iQueryable completely, but if you write queries, certain queries are happy in the in-memory implementation of SQL, of EF, but as soon as you deploy them in real world, they essentially do enumerable. So they get the entire SQL database in memory and then start enumerating. So something that takes half a second, if written properly, starts taking 40 seconds now. So that's again another violation of another elementary geometry. Square is a rectangle. Is square a rectangle?
Yes.
Are you sure?
Yes.
It's got to have 4 even sides, doesn't it? Like the same length.
Okay, think software, don't think math. Okay, square is not a rectangle. Okay, rectangle, the guarantee of a base class, if rectangle were to be the base class and square were to be derived class, the rectangle specification clearly says that its 2 sides or its 4 sides may or may not be equal. Square on the other hand says that all the 4 sides have to be equal. So if you derive square from a rectangle, you are essentially violating the base class's guarantee. So square is not a rectangle from a square point, from a computer point, from computer like coding point of view. From math point of view, sure, right? Square is a rectangle. So this is where it becomes really subtle. This is where we start violating, and kind of this is where. Anyway, LSP makes the system manageable, reusable, and robust simply because now if assuming that the implementer of the base class has taken care of the guarantees of the interface, you can essentially replace. You don't have to worry about testing for each subclass. Again, this is a minefield, but again, this is a skill, right? So you make mistakes and eventually you learn it. Violation of LSP is obviously a violation of OCP, right? So if you jack in a 440-volt USB port into your laptop, that's a violation of OCP. It's no longer, it's going to be a bomb. All right. Again, validity is not intrinsic. It can only be expressed in terms of clients, right? So it's not a generic principle. Again, you need to take a assessment of what you are going to be doing, and within the realm of that, within the scope of that, is what you want to be doing. How many slides am I behind?
Yeah, it's slide 20, 19. So about 6 behind.
6 behind, okay. Catch up. Okay, again, do not overdo. So if you're overdoing, somebody has not called or somebody has violated EDMI somewhere. right? But again, right? Don't surrender it lightly, because if you get the point, right? So you lose a lot of stuff. If done carefully, this is actually a very powerful, right? Okay, let's apply it. So a new requirement has come in from the product owner. He says, now the customers change their mind and they want the contents to come from a DB. Okay, we don't have an option but to implement it. We could do it like this, but what's the problem with this?
You've had to modify the format reader, the bunch of stuff.
Not quite. Think in terms of LSP. Like some class here is not obeying the guaranteed service at a instinctive level. Some class here does not.
So the file format reader is not reading from a file.
Yes. Right. So reading from a database. So it's technically reading from a file, but semantic wise, that's not the thing that you want to be reading from a file, right? It's reading the connection string, but that's not. We want to be getting the content, right? So it's very subtle here, right? But then what happens is, again, the database has its own characteristics and from the file and the XML file. So while flat file and XML file are more or less the same, you do a file open and blah blah blah. Database is not, right? So this is essentially a violation of. And even take a look, right? So the database is somewhere else. The database connection file is somewhere else. Essentially,
You need a connection between the database file, so the connection file and the.
yes, but that's not the content we're reading, right? That's just a pointer to the contents. So the contents are going to come from the DB. So the file format reader interface, what it says is, if I implement something, I will give you the contents from where I'm implementing it from. But here he's giving the connection string. So somebody has to take the connection string and connect to the DB somewhere else. So you've just violated the guarantee of that file format reader. So it's not really reading the content. It's not really reading the.
Basically, you need this statement in the file reader service to decide to check if it's a database connection file.
Yes. So this is essentially a leak of responsibility. There's a leak, right? There's a clear leak here. So you wanted to hide the content, obtaining the content below the file format reader, but it actually now, as you said, right? So file reader has to be now aware of DB and blah blah blah. So then you typically refactor it to this, right? So there's a file service reader that does, again, the naming has become very now. So earlier it was hard to name, or the name was misleading. Now it's become pretty nameable. Right, so this is one of the things you can do, right? So this aligns you with LSP. Now, interface segregation principle, it's fairly simple. It's the single responsibility for, think of it that way, right? Now, statement is clients should not be forced to depend on methods they do not use, right? It all sounds abstract, but let's get into real. What's a real world example? HDMI port versus display port, right? Now,
you're saying it's like putting HDMI port when people only use display ports?
Or saying that every device has to support both, right? So yeah. if you are saying that I'm only going to give one sort of port for my laptop, that means everybody has to align with that. Well, people don't need to necessarily. They might have different requirements, and so you're not forcing them to. Or you can say they have to align with both HDMI and a display port, and that's not feasible. So that's an example of ISP. So you just want to segregate interfaces for what the client wants. Why? Separate clients meet separate interfaces. Again, so if a particular client is implementing interface that it is not related to, then it might end up taking dependency on that particular interface that it's not using. Okay, and then subsequently when it changes, there's going to be a transmission of force through that interface that it really did not need to depend on in the first place. Right, so this is essentially how well you're shielding your other clients. So now the client who implements HDMI port, even if he cannot simply make changes with respect to display port. So it's as simple as that. But if you mix the two, then you might have changed something in the display port and HDMI port, and therefore all your clients now need to refresh with the new specifications. That's how it goes on. So it's sort of a mess. Now, However, for coding, right, like you don't want to split your methods into your classes into multiple classes that implement. You can have one class implementing all those individual cohesive interfaces, right? But what the client get is a view of that class with just that interface, right? So that's the trick here. Again, don't overdo, right? So if there are certain, it's okay to say client groups instead of each client, right? So logically, sorry, I'm not able to give examples with EDMI code base because I'm not familiar with the code base yet or the design, but I'm sure, or if you guys want to stop me and give an example of the EDMI system, I'm happy to pause. Right, that's fine. So let's apply it. So there's an issue with the email sender. What is the issue? Again, hint, I guess, use ISP. Sorry? It's doing all three operations. Give yourself a chocolate. Right, it's doing too many things. Right, you just split it and look at this. Naming becomes nice, much nicer. Okay, so the last one, dependency inversion principle. This is the genesis of DI containers. Okay, statement is, this one is a little bit mouthy. So higher level modules should not depend on, lower level modules, both should depend on abstraction. There's a second part, equally important. Abstraction should not depend on details, details should depend on abstractions. I mean, clearly. Right, what's a real world example here? I mean, I'm going to give an example here, but if you have another example, shoot it, you get a chocolate anyway. So credit card abstraction, right? So your credit card is just a token for you, right? And the guy at the counter who's accepting your credit card really doesn't care whether it's Visa or MasterCard. Well, sometimes he does. They don't accept Amex, but let's leave Amex out of it, right? So it's really, it's standing for a credit card, and the clients, which is you and me, or the consumers of that, really don't depend on what is the underlying authentication and whatever economic going behind under the scene between Visa and MasterCard, right? So that's an example. Why? Okay. Now here this is the subtle part, right? So this is the inversion of both dependency and ownership, right? So you're not only inverting. We'll come to that in the subsequent thing. This is the one that we'll follow the transmission of forces analogy here, right? Again, don't start overdoing it. So call out Yagni, feel free. Now the thing is, if it is inversion of just, we'll come to this. We'll show you this. I think this is best done in the context of a picture. And the other one is obviously, don't apply dip to types that don't change unpredictably. So if it's system.string or system.int, don't bother. I mean, they're fine. It's only for classes and only for units that are sort of under revision, constant revision. That's why we want to prevent. Int is not going to stretch. They're not going to have back compat issues in int. Not going to have back compat. This is like a 15-year-old, 20-year-old stable technology. Now, what's the application for this, right? Now, here's a design smell with the overall app, right? What is it? Use dip.
The database reader can only access that one database. There's no sort of ability to have an interface to swap out that database with another type of database.
You mean like a SQL versus a Mongo?
Yep, or even another type altogether, yeah.
If you do that, you will have to change the email sender app. That's correct. Yes, agreed. Chocolate for you as well. Right. Now, here what is happening is the higher level policies depend on low level implementation details. And what you said, sorry, I don't know your name. What you said is a subset of subset of. This is like a general principle here, right? So email sender app now depends on everything, right? So if you want to test email sender app or actually probably will not test unit test email sender. Let's say you want to unit test file reader service, right? So then, you kind of, actually that's not the right example. So the part in email sender app that essentially consumes this, if you want to unit test that part, right, you will pull in the entire database reader service and you will pull in the entire file reader service. So that's the problem here, right? Now, ownership direction also needs to be fixed. So if the database reader service for some reason changed the method that it exposed to email sender, then guess what? Email sender has to change and you have to retest the entire thing, all the flows. So that's what is meant by ownership. So the interface between so right now the ownership of the interface between database reader service and email sender lies with database reader service. So that's where the ownership of the interface lies. You want to flip that as well, so that it's the database reader service that adheres to the requirements of email sender, not the other way around, right? So this becomes this. So you've just flipped the arrows and you have flipped the interfaces, right? So now the database reader service adheres to the specification of processing service through iMessage info retriever, right? So that's the flip. So there are two flips here. So that's it's not just a flip of dependency, but it's also a flip of ownership, right? So that's the key. That's the subtle part of this, right? All right. So clean code, all well and good. We had this before and we have this now, like, okay. So it might be a relevant question to ask, why on earth are we complicating an otherwise simple thing? But wait, we're not complicating because we delivered two features, remember, and we followed this, right? Consistently across the way, along the way, we followed this, right? And what do we get for this, right? We have low coupling. The entire system is decoupled. Individual pieces can be pulled out, replaced. Each piece can change independently. The force transmission is minimal, right? And guess what? You can add new functionality easily. Like somebody said, MongoDB. Well, go for it. Add it, right? You probably just need to change. Actually, you don't even have to change. If you use dependency injection, I think you're taken care of already, or maybe one file. Right? High cohesion. So the cohesion is, you can spot the cohesion by how easy it is to name, right? So each name here essentially does what the name is. So that's what is the meaning of cohesion, right? So there's each name is very specific and it exactly reflects what that component does. So that's the cohesion part, right? And each works well by itself, but when coordinated, it achieves a bigger goal. And you can reuse, right? The file reader service now can be pulled out and reused into some other app that you might have down the line. Or DB reader is small pieces of code, but you get the idea. As system grows bigger, your reusable pieces. So you're essentially coded for tomorrow, but designed for today, not the other way around, right? And of course, good encapsulation, right? Like for example, you can test each part of the app independently. You can change the parts of the app without touching the rest of the app. Integration tests become easier. Actually, you probably need very less integration tests at this point because you need to still take care of most of the stuff. Now, this is what we're after, right? So now we've seen why code rots. 3 reasons, right? What are the 3 reasons? So the change is done by somebody who is not aware of the original design philosophy. Change needs to be done fast. And what's the third one? Not scope creep.
Requirements
change unpredictably. That's the third one. You get a chocolate. Feel free to collect it. Okay, and what we have done is we have detected with engineering practice. This is the loop we have followed, right? We've diagnosed, we've applied the clean code principles, and we've come up with something. So that's the refactoring that was going on constantly under the thing, right? So the refactoring is the goal here, not design, not tests, right? Now refactoring sprees is something that I used to do. I don't know if we do it in EDMI, but it's actually a pretty fun way. Just take a piece of code, and you would have already identified some of the problems with it upfront, and then kind of 2 of us or 3 of us, 4 of us just get into a room and just kind of just go for it, like go caveman on that piece of code. Right. Now this of course by itself is not sufficient. It requires a balanced set of tests, developer tests, all around, not just unit tests, integration tests, and end-to-end acceptance tests, and a good automated engineering pipeline, something like what we have in EDMI today, right, where you can essentially push in the code and see how well it goes. It's all about your gates and stages and things like that. These are the topic for the next set of talks. I'll summarize key takeaways. Thanks for sticking around. Design smells, you can remember like this, right? Frivolity can ruin oneself. So FRIB and CRO. So fragility, rigidity, immobility, viscosity, complexity, repetition, and opacity. YAGNI, dry. Solid is an art, applies to life, not just software. I think it might, the slide that I showed earlier where somebody was drinking too much of the FP Kool-Aid down, it should be obvious how silly that slide is. Right, and typically the way to think of solid is if you underdo, like underdo as in opposite of overdo, you will violate dry somewhere, right? And if you're overdoing it, somebody is violating YAGNI somewhere. So this is typically kind of the way to look at it. And along the way, deliver features and do this loop, right? This is what the takeaway for this. All knowledge required for this, all the content also for this comes from these. Actually, the top 3 books. The 4th one is the topic of the 3rd session, but this is essentially the wisdom of our forefathers, Ken Beck, Robert Martin, and Michael Feathers. So this is all right here, right? These guys are good. These guys are really good. They know what they're talking. Right, and this is of course us.
Great, thank you.
Thanks.
You're welcome.
Nice one, Pather.
I have learned a lot.
Thank you.
We're going to go away and code now.
I might go away and improve. I might go away and improve some PowerShell.
The code, the implementation of the code really doesn't matter. It could be PowerShell, JavaScript. It could be a make file. Doesn't matter anymore. It's just so thank you guys. I will end the slide. I'm happy to stick around for questions and discussion, or even just random chatter on this topic, or any topic for that matter. Like this is really a fun topic for me. I get all excited. Hopefully I didn't screw up the presentation due to my excitement.
Thank you.
That's good.
Thank you.